All right, here we get started on the content from tonight's homework. This is to go through this review and help you out with how to start these problems if you're not quite remembering how to do them. So here we go. We're first looking at, is this system set up to solve easily with substitution or elimination? Remember that if we see a variable isolated, that's set up nicely for substitution. If we see opposites above each other in standard form, that's set up nicely for elimination. So this first one is going to be a substitution. Notice that y equals all of this. So I can go ahead and rewrite this equation, getting it ready to plug in for y. So plugging in 6x minus 1 in for y. Now we distribute that invisible -1. And negative times positive, negative times negative. Double check your signs there. Combine like terms. Subtract the 1. And we have half an answer. X equals -5. Remember that we now need to take the x value, plug back into either equation to get the y value. I'm going to choose the nice, isolated, easier equation. So I'm getting that x equals -5 and y equals -31, and then we put that answer together in coordinate form. That is the solution to this system of equations. Imagine that I could graph the first line, graph the second line, and I would get one point where they touch, and that specific point is -5, -31 in this case. Let's look at the next one set up for elimination. I already have opposites. How nice. Now we're just going to do linear combination on the rest. Add this line up, add this line up. Oops, sorry, that's your positive. And that equals -1. So that gives me half an answer. Take that answer, put it back into either equation. And again, I take that x equals 4 and that y equals 1, and I put them together into coordinate form. All right, that's our systems of equations review on this homework. Let's go take a look at review of an arithmetic sequence with a recursive and an explicit. So if we look at the negative jumping to this positive, our brain may not be able to comprehend those movement forward and how much that is. So my hint is to ignore that negative for a second and just look at the 3 to the 8 or the 8 to the 13. How much is that jumping by? It's going up by 5. Remember that that's called a common difference or a rate of change or just good plain old slope. So if the common difference is 5, here I go writing the recursive. F of 1 equals -2, f of n equals f of n minus 1 plus 5. How do we know this is a time 1? Remember that all sequences with no numbers with it, it's not given in a table, we assume it's beginning at step 1. So explicit function goes f of n equals, begins with -2, adding 5 every time to the 1 before time 1. So here's my nice explicit function. Finally, the 27th term. It means we're going to use this explicit function. Given the input of 27, we want to get the output. So f at 27 would be what? So use your PEMDAS skills. 27 minus 1, that's 26. 26 times 5, I need my calculator, so you probably do too. 26 times 5 is 130, and 130 minus 2 is 128. I'm getting that f at 27 is equal to 128. Given this input of 27, I get an output of 28. This is your x value, this is your y value. Okay, let's go look at the next one. This one is going down by something. Did you notice that it was going down by 4? All right, let's write our recursive. F of 1 equals 20, f of n equals f of n minus 1, minus 4 every time to the 1 before. And explicit begins with 20, subtracting 4 every time to the 1 before time 1. Which term in the sequence is equal to -52? This is giving us now an output and asking, when it says which term, it wants to know what the input is. What is the n value that goes with an f of n of negative 52? So when I go to use the explicit this time, and I'm going to plug in, am I going to plug in over here or over here? Well, when I'm given an output, it gets plugged in at the front. And now we're going to solve backwards to get our plain n. So distribute the negative 4, combine like terms, subtract 24, negative 76, and when I divide that on a calculator, I get 19. I got an input of 19 or an output of negative 52. All right, let's check out the next one, a geometric sequence. All right, the first one Ms. Sanchez put on this Bellwork was kind of mean. Those of you that got to it would be like, I thought it was pretty crazy. Remember that when we're going up by a multiplier, it's geometric. It comes out to an exponential function. How do I know this is timesing by 3? I could have gone off to the side and done this on a calculator. What is 135 divided by the previous term? Oh, well, that's 3. What is 45 divided by 15, the previous term? Well, that's 3. What is 15 divided by 5, the previous term? Well, that's 3. By dividing the second term by the third term by the second term, etc., we can find that multiplier by dividing. We're going to use that especially on the next one. So your recursive function, f of 1 equals 5, f of n equals f of n minus 1 times 3. And how does the explicit look different? Begins with 5 times 3. Every time to the 1 before time 1. When you are repeatedly multiplying something, how do we represent that in math? We represent repeated multiplication with an exponent. So remember that the n minus 1 on a geometric needs to be a little tiny n minus 1. Which term in the sequence is equal to 12, 15? Well, that's a super big number, and we actually don't have the tools yet ready to be able to work an equation backwards, where the output is 12, 15, and it's 5 times 3 to the power of I don't know. This is using logarithms. Later in life, you're going to be able to use logarithms to solve this backwards. But for now, the only tool we could possibly use is to do a guess and check. So I'm going to start with something easy like 3. 3 minus 1 is 3 squared. 5 times 9, or 3 squared, is 45. That is way too low. So now I'm going to guess higher, guess lower, keep adjusting from there. You're going to do a guess and check until you find the correct input. So once doing your guess and check, the correct input happened to be a 6. So if I do 5 times 3 to the 6 minus 1, 5 times 3 to the 5th in your calculator, that came out to 1215. So those of you that actually tried this really mean problem that Ms. Sanchez gave you that required a guess and check, the answer was 6. Last but not least, what the heck is happening to this one? It's going down. So if we go off to the side and do the divide thing, 216 divided by 324, that comes out to 0.6666667, rounded. What if I do 324 divided by 486? Comes out to 0.66667. And so we realize that my multiplier is 2/3. It's possible to have a fractional multiplier. If you guys remember, this is called a common ratio instead of a common difference when we're multiplying something. So here I go with my recursive. F of 1 equals 729. F of n equals f of n minus 1 times 2/3. F of n equals, begins with 729, multiplying by 2/3 to the power of little tiny n minus time 1. Now we're going input output. Begins with 729 times 2/3, little tiny n minus 1. And they're asking us for an input of 6. What would the output be? I recommend you use a Desmos calculator, scientific calculator for this. I'm doing 729 times 2/3 to the power of 5. You should have gotten 96. Thanks for watching.